A group of earthquake scientists who were battling in the literature over earthquake prediction methods recently held a series of meetings at the John Wesley Powell Center, a U.S. Geological Survey retreat in the Rockies, to hash out their differences. Here, Jill Barron of the center and two of the seismologists, Mark Sterling and Ross Stein, describe how mountain hikes, a focus on data, and even a Powell Blood Oath helped clarify new paths to improving disaster predictions. What was the issue on the floor? And maybe, Mark, do you want to just sort of give an overview of what prompted the need for this?
Yeah, sure. Basically, we had a lot of debate in the literature about the methods that we use in seismic hazard assessment, mainly probabilistic seismic hazard assessment, in that there'd been a lot of significant earthquakes, tsunami events, devastating events around the world that had happened in relatively short succession, such as Tohoku earthquake in Japan, Haiti earthquake, Christchurch earthquake in New Zealand, etc. And a number of critics got into the literature and said seismic hazard methods are effectively bogus. They don't save lives. These hazard methods are forecasting low levels of hazard in some of these areas that have had major devastating events. And either that or there was criticisms that the various seismic hazard models, the national models that have been developed, had underestimated some critical earthquake measures, such as the largest earthquake that could happen offshore from Japan. So there were some pretty strong criticisms in the literature, and those sorts of criticisms are quite damaging in our field of work, seismic hazard analysis. That's very easy to cause a big reduction in confidence in what we do. And so there was a lot of that going around, and that prompted Ross and I to start talking about should we just really go beyond what's happening in the literature, which was comments and replies, people talking past each other. Ross and I thought, well, let's do this in a really in-your-face sort of way and get all these people in the same place. And Ross thought about the Powell Center as the ideal venue for this.
So Jill, what the heck is the Powell Center? I have never heard of it before this, but I really like the idea the concept that I saw laid out looks really interesting.
So we're relatively new. We, I think, are in our 6th year now of activity, but we started as a shameless clone of the National Center for Ecological Analysis and Synthesis, which was an NSF-sponsored synthesis center based out of Santa Barbara for 15 years. And what they did is very similar to us. They announced a competition for teams of scientists with great ideas, with complex ideas, with potential big impact to propose to come there for some period of time and work as a team of scientists to put out their ideas. So we are funded primarily by the U.S. Geological Survey, and that was novel because this is the first center, actually the first center anywhere that is meant for all scientists, but with specific inclusion of government scientists, on the premise that we're all civil servants working for the public good. And Ross and Mark put together this proposal. It came to my science advisory board, and it floated directly to the top as one of the most compelling of that year's crop.
You know, the other thing, Mark mentioned that this had become an issue in the literature, but at least in Italy, it became an issue in the court. I mean, it was a criminal effort to sort of get bad prediction became kind of a criminal offense. But I don't want to focus on that too much. But this really has become kind of a big issue. So what's your take briefly, and then
Well, of course, that's true. The L'Aquila case casts a shadow over everybody's work. And in the United States, there's been a vitriolic battle between Seth Stein, a very distinguished scientist, and the USGS on the hazard in the New Madrid area, which has kind of embittered a lot of people and caused everybody to go to their corner. And then there was as Mark alluded to, after the Tohoku earthquake, which was so much larger than expected, there was a general kind of revulsion about this. So the USGS is sitting here committed to providing information to the public. Many scientists are against it. How are we going to really address these issues in a manner that we change our thinking? So the idea of the dialogue was that people needed not to be only an advocate, but also an arbiter. And that fundamentally what everybody was there to do was to listen, which can be very hard. We don't do much of it. We just wait our turn to talk. And to be humble, which is easier to do when the press isn't there, to be honorable and to be seen as honorable, and to relinquish control. And by that I mean control of the podium, control of the slides, control of the minutes. It seemed to us that if we could all agree that those were the ground rules, then we could start a dialogue that didn't just pick up where the fight left off.
And so how this played out over a period of time? The other thing was interesting, it's not just a one-time meeting, like a smackdown.
Right.
Maybe
and I think,
yeah.
That just in a quick reply, that was essential because there.
That's okay.
Apologies. That's why I had you on mute before. Go ahead.
People needed to have an attitude shift. You can't do that in one meeting.
Right.
So we had two different groups that each met 2 times. And so we could hope for and see some shifting of attitudes over a protracted period that wouldn't have happened if we had tried to just resolve it all at one meeting.
And that was planned from the get-go? You always knew there would be more than one?
Yes, there would be 4 with these 2 different groups.
Right. So Jill, maybe you could take me through the process, because there's a template here, I assume, that you would apply to various kinds of questions.
There is a template, but one of the things that I think makes us very successful is that we try to be as flexible as possible. And that's actually one of the success stories. Government is not known for its flexibility, but we've been making this happen, which is great. The template is that working groups, and that's what they're called, of 15 to 20 people or fewer come together for a week at a time over the course of 1 to 2, sometimes 3 or 4 years. And in between, they spend a tremendous amount of time thinking, collecting data, collaborating on data analysis, running models. And we also provide them with a postdoctoral fellow. I'm not sure we gave you guys a postdoc. You might have been too early in the system.
We didn't. I don't think we even asked for that.
No, we didn't.
Well, we realized the error of our ways and recognized that a postdoctoral fellow was the glue that made all of this happen. Mm-hmm. So they come together for a week at a time in Fort Collins, Colorado. We have a lovely space. We're at the foothills of the Rocky Mountains. And we basically give them a room and croissants and excellent coffee and let them duke it out. And we also, when asked, and I don't think that either of you did, but you might have, we offer ideas on how to make successful collaborations happen. So one of these things, and Ross and Mark broke these rules immediately, was you do not invite prima donnas to the room because they will dominate. And of course, your field is full of people with high egos and large opinions, and that was the point, to bring them to the room, and then you took it from there. So I'll pass it back to them.
So Mark, maybe you could offer some vignettes of how this played out. In terms specifically, let's start with that issue of everyone, I assume, knew you were getting into a room with people who had fundamental disagreements. So were there any moments that kind of sort of clarified how this might move forward?
Well, I think we never really had any major conflicts in the meetings. I mean, the way that we started it out. I mean, obviously we said why we were there, and then we had everyone introduce themselves, and then we got people to present some of their ideas related to the topics, and that was just a natural segue into some of the conversations. And it was the discussion times between the talks that where we started to talk, realize, okay, here are the issues, here are the solid points that a person is trying to raise, here are the good things about the methods of seismic hazard analysis. And we gradually got people like Seth Stein starting to say, well, okay, here is what I think is PSHA, probabilistic seismic hazard analysis, is producing, and that is useful, and here are its limitations. And this is sort of something that happened during the course of the meetings. There was an evolution, and what has come out of this has been publications by PSHA critics like Seth Stein that have showed what PSHA can usefully produce. And so that was the paradigm shift. And Seth Stein, as Jill and Ross know, has been quite prolific with Powell Center publications, and we are on a very good communication path now, rather than being people, as Ross says, stuck in our corners with our entrenched ideas. And the other there's another couple of things. I mean, Ross can maybe talk to the gear effort, which was another big thing to come out of this Powell Center initiative. But I must say that one of the big positive times for collaborative discussions was the times where we went into the Rocky Mountains hiking for an afternoon. And that was an amazing place for collaborative discussion. And that was something that Jill put to us at first. This is how we usually do things. We usually get you guys all together, and in the middle of it, you go out into the mountains. And we thought, well, that'll be nice time out. It was lovely time out, but it was actually some of the best discussion and progress that we made in terms of our goals of the workshops.
So actually, I want to circle back to Jill then. And ask you also, what's the Powell Vow? I think it was called the Powell Vow. There was
Blood Oath.
The oath. Okay, but first, before we get to the Powell Oath, I think the piece mentioned that high altitude and strenuous walking limits the potential for blowhardness. Is that true?
It's definitely true. So this is something we actually require of our working groups, and even though we get pushback from some government administrators, unstructured time like this is extremely valuable for creativity, for lowering these kinds of barriers between people, for allowing people who are normally shy to get more comfortable talking to whomever's next to them on the trail. So when people come to the Powell Center, we insist that they take a half or a full day off. We give them cars, we send them off in various directions. And the result has been written most eloquently by Mark and Ross, but many groups come back and say, that was the most valuable time of the entire week.
Yeah,
and we were not staring at each other intensely with some sort of objective on our mind.
Right.
Yeah. Right. Yeah.
Ross, could you get at that a little bit? You brought up that idea that I see all the time, which is people are usually not really in a conversation. They're really just waiting for their turn.
Yes.
Is there some moment when you saw true communication happening that sort of reflects this? It might not be easy to...
Well, first, the blood oath, which is that you can advocate for your position as strongly as you want, but you must also talk about the weakness of your position, had a very large impact, not only in the room, but on the hike. In other words, we weren't telling people that you had to just find a consensus or abandon your view. You simply had to describe what were the things that your view couldn't work. And quite often in discussion, when I found myself advocating for my position, someone would say, okay, Ross, but what's wrong with that? What are the things that aren't working? And suddenly I would have to do the same thing. And then I didn't sound so hot anymore. So that has a very strong impact. Suddenly you're humble again. You're not grandstanding. And the further thing that happens on the hike, I don't know about you, but when I really wanted to have a heart-to-heart talk with my daughters when they were growing up, it was basically in the car when we were both facing forward. And what happened in particular with the antagonist is those hikes where you're not facing each other and you really have to conserve your breath. Suddenly it changes your willingness to have a deeper discussion. You feel it's more private and intimate, and everybody doesn't have to hear it. If you say something that you wish you hadn't, or is more of an admission than you would do in a full group. So both of those things contributed for people's willingness to see things differently. Another thing that we tried to do is we tried to bring theoretical academic scientists together, government scientists who have some responsibility to society's needs, and industry scientists. And what we found from that is that pure scientists really do also want to contribute to society, and practitioners really do want to contribute to science. And that was a beautiful thing that we hadn't foreseen that pulled people together.
That's fascinating. Well, there's so many arenas now where we're getting people to examine what's called the public-private interface in dealing with resilient cities, which we did at Pace University. We've had 2 meetings focused specifically on that, getting people out of these silos, both within society and also within this interdisciplinarity. It seems really important. I would love, and actually I should see the list of who else has come to the Powell Center, but I've seen discussions about the extent of methane outgassing that could happen from the Arctic is one of these very tough issues. People are, fighting to the death over. And there, within just climate change, there's many other questions like that. One thing I've advocated for in the past is to get like climate modelers and the observational community to hash it out, because I see these questions always between sort of the people observing sea ice up in the Arctic and people modeling sea ice from Boulder who have never seen sea ice. And it's like they need a field trip, essentially. So there's something in this model you're on, I think, that's really valuable. Now, I wanted to get to the sort of where the rubber meets the road question, which is, sitting in Portland, Oregon, or in Istanbul, or wherever you are, where there's substantial earthquake hazard. What has happened in the last couple of years through this meeting process that looks like it's going to help clarify how to go forward?
Well, a couple of things that are important. One, we were able to bring people together from different parts of the world who all went about the problem of forecasting earthquakes to the best of their ability, but they suddenly were in contact with people with a very similar problem using different methods. And that made us all realize that none of these methods we should have a lot of confidence in. And therefore, what we should be doing is developing any test that we can. We're never going to be able to improve it. If we get rid of the problem of our desire to assure the public we're giving them the, quote, best available science, then really our job is, what can we test here and what can't we? And so we tried to focus our attention not on who's right and who's wrong, but where do the different people around the room think there's an opportunity to build something new that is truly testable? And one of the outgrowths of that was what Mark was referring to as the GEAR model, which stands for Global Earthquake Activity Rate. But we call ourselves the gearheads, so that was the reason why we chose that acronym. And the GEAR model tries to create a global testable earthquake forecast. And the huge benefit of doing this in a global manner is that if you're willing to test the occurrence of magnitude, let's say 5 3/4 earthquakes and larger, you can test the model in a year because there's 200 or 300 of them. Whereas if you're just going to do this for California, you'd have to wait several hundred years. So you're out of luck. So to do a global model, you're going to have to give up on a lot of things because we don't have the beautifully detailed picture of California faults. But it forces us to create something that's reproducible, that's testable, that is basically a test bed for anybody else's ideas, that all can be tested. So in a way, kind of an open competition. And that model grew out of these discussions, has just been accepted for publication, has just been submitted to testing. And the goal is, hey, beat it. You know, it's not just a matter of whether or not this model does well or doesn't do. Come up with something else, beat it. Let's all work toward something testable, because the big fear is that if it isn't testable, it isn't science, regardless of its societal value. And this was the argument of many of the people like David Jackson, who are other critics of seismic hazard analysis, that say, you're not doing science. Maybe you're doing good for society, but it isn't science. And that strikes a very deep and kind of painful chord. And so acknowledging that, yeah, we're not doing what we should be, let's come together. That was one example among several others that came out of this kind of rebirth of an attempt to say, whatever we're going to do, it's got to be tested.
Yeah. Would you say overall that on the most catastrophic quakes, have things been rolled back in terms of the sense of capacity to understand them, given the Japanese quake? Haiti came out of the blue in a certain sense. I mean, there was some sense of that risk. You just saw my friend Catherine Schultz's New Yorker article on Cascadia, and I've been writing about that on the blog for years, where some of these things they remind me, might sound weird. My first big story at the New York Times in 1996 was about the crash of Flight 800, a Boeing 747 that blew up and fell into the ocean, killing 232 people off of Long Island. And everyone thought, oh, it was a bomb, it was a missile. Slowly but surely it became clear it was some pretty weird multiple factor failure, of electromechanical failure, that even though... And it got me thinking that, with aviation, that these things are so rare now that everyone is basically a novel event. Meaning, and to me, there's a certain novelty factor in some of the earthquakes that have happened recently where I'm not sure I see much potential for clarifying predictability in certain ways. Is there, I guess, getting back to what you were saying about what you can publish on, which of these categories, the catastrophic ones, the sort of medium scale quakes, is there a sense that there's progress is more possible on some level of earthquake than others?
Yeah.
Well, the problem is when you get to testing, and you cannot test the occurrence rate of huge earthquakes. They're too rare. Right. So in a sense, you will never be able to prove that you can do a good job with magnitude 9 events. Right. And so what you have to do instead is do a good job on magnitude 6 events and develop some credibility for scaling those up. So this is why being humble is really important. And, if anything, people realize that the Japanese made overarching assumptions about the repeat behavior of earthquakes that were not justified. Yeah. And so we have to make sure we're not doing that as well. And so there's lots of ways in which being humble can make us better at this, or at least not make the same mistakes that were made. Cascadia is another one. We've tended to assume that the place only produces magnitude 9s. That can be a complete misreading of the tea leaves. At the very least, if it were true, it's extremely unique. So on that basis, maybe again, we're making the opposite mistake that the Japanese made. They assumed that they could never get a magnitude 9. We're assuming almost that we can only get a magnitude 9. We're probably both wrong. And a global perspective helps, but is not a panacea. So, a lot of this has to do with just all of us owning up to what we don't know and what we can't say.
Yeah.
I could add there that in the industry, in PSHA, in probabilistic seismic hazard analysis, with these big events and devastating events in low seismicity areas, there's been a big move towards more fully quantifying uncertainty. And there's an example that is of these big magnitude 9 earthquakes in New Zealand. They've now been entertained in our latest seismic hazard model as a result of Tohoku and some of the other megaquakes, and as well as the possibility of lesser but still damaging events. There's a lot of research now going into ground motion uncertainty. When you get an earthquake of a certain size and a certain distance, what is the range of shaking that you're going to get? That's very important. There's the big push on so-called time-dependent seismic hazard, where you're saying not just on average you expect this level of shaking, or you expect this probability of earthquakes, but you can say in the next 50 years we have this probability. Our building code for Christchurch now is a time-dependent model where we have basically forecasted an elevated level of seismic hazard for the next 50 years, because we want our buildings protected for that higher level of hazard. So this is the sort of thing that's come out generally with these earthquakes. And, you know, as Ross said, the Powell Center has had a place in that progress.
Yeah, so Jill, you know, you get to sort of sit on the sidelines and watch this all play out. What's your sense of what you see as this has happened through the course of the sequence of meetings?
Some of these, we've now had about 37 of these working groups. They're all on our website, and I'll send you that link. And some of them have been monumentally successful, and I would count this one as one of them. Some of the others, it's always a gamble. Some of them come together, and even though we offer unlimited computing power, sometimes it takes them several more years than they thought to actually get it together, or they couldn't actually pull it off. But most of our groups are now very productive. And what's so exciting is that because we lower the activation energy for bringing groups like this together, they can focus on their science. They can focus on the bonding and the trust that is so essential, as Ross and Mark have described, to moving these ideas forward. So it's tremendously enriching. This is not my day job. I actually have a real research scientist position, but this is among the most satisfying things I do.
And did you get the sense, does everyone just return to their corners afterwards and go into the literature?
No.
Maybe Ross.
No, not with the way the publications have gone and the collaborations. It's been very rich since then.
Good.
There is a social science branch made up of maybe two people, maybe more, Ed Hackett and John Parker from Arizona State University. And they actually study the dynamics of groups like this. And John was recently at our center, and I call it radio callers. He collars every participant, and he actually measures the dynamics going on within the group. This was the group on dam removal. It had a very nice paper in Science just a couple weeks ago. And then he follows them longitudinally over time.
Wow.
And he's been doing this for other synthesis centers to say, does it really change the culture of how people interact? And they are finding that most definitely yes, because it's so enjoyable to move the science, and it's so rapid to move the science forward this way, that the people don't go back to their corners when they're done. They continue to collaborate with each other. Some of them, the students especially, take that collaborative mode and employ it in their other interactions. So slowly, ever so slowly, we hope that we're transforming the culture of how these big complex questions are tackled and hopefully solved.
Well, just one last question, which is I could see a process like this sort of having a second iteration where you then open it up to stakeholders, meaning earthquake engineers. Like You know what I mean? Unless that's already part of the process.
We have insurance company people who were there, who, if you like, are the uptake end of this operation. And that was really important because they were seeing, perhaps for the first time, how uncertain so much of what they place their financial bets on is.
Yeah.
And they were saying to us, it was kind of interesting with respect, Andrew, to your comment about Tohoku. They say Tohoku doesn't worry us anything as much as a big earthquake in Sydney, where we're even running much more blind. Whatever we did wrong in Tohoku, we'll do it wrong by a factor of 10 in Sydney. We don't have a clue.
Right.
So that's important for us to hear, because we tend to focus on certain mistakes we've made and earthquake-prone areas, but they think about the consequences.
Right. Yeah. Well, there you go.
Hey, Joe? There's another group that is meeting right now. They just held their first meeting earlier this spring called Operational Earthquake Forecasting, and it's a takeoff on what you guys started. They had a meeting for 4 days earlier this year, and for the first 2 days, all they brought in were practitioners. So they had the representative from the LA public schools and the representative from hospitals in California. And what they did for these first 2 days is they listened to these people, these practitioners, tell them how they need information in order to be more effective at forecasting, to taking those forecasts and putting them to use. So it's starting with the practitioners in this case, and then moving to, okay, let's design the science around that.
Well, and yeah, that does make sense, because it's it's like my science teacher wife used to start with, what is it you want students to take away from your course? And then you kind of build it backwards. Although in science, I mean, just one last thing. This is the, again, maybe the academic scientists particularly are so, there's almost a disincentive to be meaningful to the public in some disciplines, and that gets at the some of the academic sort of structural impediments to perhaps this model. Being a Future Earth, which I've been involved in, I was the interim engagement committee person on Future Earth, is designed to have stakeholder interactivity with science for sustainability. And to me, sustainability includes making sure stages don't fall down too badly in a big earthquake. But I know that there's resistance. There is resistance, certainly in some disciplines, to doing that.
Yeah.
Ross?
One thing that I want to emphasize before we close off is that one modest element of Jill's center that's very important that I had never seen before is this idea that you sit around a square table where everybody's laptop is plugged into the projector. And then you just have a toggle switch when you want to project your slides. And you get rid of the lectern, and it changes the dynamic completely. You're not just sitting there quietly waiting for the other idiot to finish. What happens is people are talking, and they're talking with their slides. And if they have a comment to make, they can just throw up on the screen a couple of slides that illustrate that point. And it's a much richer dialogue than I had ever had before, and it's so simple. And no one held the stage. That was really important. Everybody could contribute. And then when you combine that with the minutes, which we did on an Etherpad that everybody could see and everybody could revise on the fly, both elements conveyed to people that no one controls this but you. And we could do that. I want to do that in every workshop now, and I have tried to do it, but in general, you can't find the equipment for that. It's a small thing that would make a big difference in everybody's program, but Jill has done it and really awoken us to the importance of that.
That sounds great. It reminds me a little bit of a meeting I went to in Woods Hole, Massachusetts a long time ago. It was sort of internet people, like some of the people who actually created the internet. And they had that same sort of interactivity. They had one detail there that was kind of fun. I don't know if there was an element in your meetings like this. David Eisenberg, who created this series of meetings called Big Hook, when you got your ID, when you got your label, you also got something called a rant card. It was like a Monopoly thing. That was it, and it gave you 2 minutes to hold the floor, but you only got one, and that was it. And you had to sort of keep keep it on hand. And everyone had to wait for their moment when you just couldn't stand it anymore. I don't know if there's a procedure like that, but it was really kind of
funny. That's good.
We actually haven't had to use that. One of our very first working groups, they insisted that we bring in a facilitator for them because they did not know each other very well. And so I paid to bring in this woman from Berkeley, and it was a total failure because she didn't talk their language, and they couldn't. You know, what we do instead is we try to do exactly what Ross says: is everybody's equal, everyone has an important opinion and a contribution to make. And the only other thing I would add is that the table's oval, not square. It's very circle.
That's good.
And above the table is a very important quote. All models are wrong, but some are useful.
Yes, I've heard that in the climate context a number of times.
Yeah, but actually that's a misquote. It's all scientists are wrong, but some are useful.
All right, this was great. I really appreciate your time.
Thanks very much for talking to us.
Thanks. And,
thanks very much, Andrew.